Your deployment is oscillating every 30 seconds, pods terminating and creating in a frantic cycle. The culprit? A 0-second scale-up stabilization window that reacts instantly to cold start CPU dips. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Kubernetes HPA Autoscaling. Kubernetes HPA is a control loop that continuously reads metrics from the metrics server or custom APIs, computes the desired number of replicas, and scales your deployment accordingly. It's like a restaurant manager opening more cash registers when the queue gets long. The HPA algorithm is proportional. It calculates the ratio of current metric to target metric and scales accordingly. For multiple metrics, it computes desired replicas for each and uses the maximum. If a pod has no metric yet, HPA assumes 100% of target for scale-up to be conservative. Here's a basic HPA configuration targeting CPU at 70% and memory at 80%. It also defines scaling behavior with stabilization windows and policies. Notice the scale-up stabilization window is 120 seconds. That's crucial to prevent flapping. The metrics server is mandatory for HPA CPU and memory scaling. It collects resource usage from each node's kubelet and exposes them through the metrics API. Without it, HPA shows unknown and won't scale. This is a production-ready metrics server deployment with TLS flags for self-signed CAs and a custom metric resolution of 15 seconds. Always include readiness and liveness probes to ensure the server is healthy. Stabilization windows are the dampening mechanism. During the window, HPA considers only the most conservative metric value, the maximum for scale-up, the minimum for scale-down. The default scale-up window is 0 seconds, which is the most common cause of flapping. Here we set asymmetric stabilization, 60 seconds for scale-up, 600 seconds for scale-down. This allows fast reaction to load spikes but slow, cautious scale-down. The policies cap the rate of change. CPU and memory don't always reflect actual load. Custom metrics like requests per second from Prometheus or external metrics like SQSQ depth make HPA application aware. But always include a CPU or memory metric as a fallback in case the custom metrics pipeline fails. This HPA uses a custom metric for HTTP requests per second and an external metric for SQSQ depth, with CPU as a fallback. The Prometheus Adapter translates Prometheus queries into the custom metrics API. The Prometheus Adapter is the most common way to expose custom metrics. It uses rules to map Prometheus time series to Kubernetes metrics. Proper configuration of series query and metrics query is essential for reliable scaling. Here's a production Helm values file for the Prometheus Adapter. It defines two custom metrics, HTTP requests per second and engine x ingress requests. The metrics query uses rate and sum to reduce cardinality. These three components form the scaling stack. HPA adds or removes pods, VPA adjusts resource requests, and Cluster Autoscaler adds nodes. The key rule: never let HPA and VPA autoscale on the same metric or you'll get a feedback loop. When using HPA with CPU or memory metrics, set VPA to off mode. This gives you recommendations without auto-applying changes, avoiding conflicts. Use VPA recommendations to right-size your resource requests. KEDA extends HPA with event-driven scaling and scale to zero. It supports 50-plus scalers like SQS, Kafka, and cron. KEDA creates HPA resources internally, so it's complementary. The trade-off is cold start latency when scaling from zero. This KEDA scaled object scales based on SQSQ depth, with scale to zero enabled. It also uses a cron trigger to prescale during business hours. The cooldown period prevents rapid scale to zero between message batches. Before you start, ensure your cluster meets the minimum requirements. Kubernetes v123+, metrics server installed and healthy, and resource requests set on all target pods. Without resource requests, HPA cannot calculate utilization and will show unknown. This deployment has CPU and memory requests set. Without these, HPA will report unable to get metrics. Always set resource requests on every container you plan to autoscale. When HPA misbehaves, check its conditions. Able to scale tells you if the HPA can scale, scaling active indicates metrics are available, and scaling limited means you've hit min or max replicas. Use kubectl describe HPA to see these. Here's the output of kubectl describe HPA. The conditions show everything is healthy. If scaling active were false, you'd know the metrics pipeline is broken. Use this command first when debugging. HPA is not a set and forget feature. It requires a reliable metrics pipeline, accurate target utilization thresholds, and a stable cluster with sufficient headroom. Without these, you'll face cascading failures. This is a checklist of minimum requirements. Ensure your cluster meets these before deploying HPA. The most common oversight is missing resource requests on pods. Start with the official metrics server Helm chart. In production, disable insecure TLS and use a valid CA bundle. Deploy 2 replicas with pod anti-affinity for high availability. Always validate the API endpoint. These Helm values configure the metrics server with secure TLS, preferred address types, and appropriate resource limits. Apply with Helm upgrade iMetrics server metrics server F values, IML N-cube system. This is the same issue we highlighted at the start. Here's exactly why that happened. The HPA had a scale-up stabilization window of 0 seconds default. When new pods started, they had low CPU during cold start, pulling the average below the 50% target. This triggered immediate scale down. Once pods terminated, CPU spiked, triggering scale-up again. The cycle repeated every 15 seconds. The fix involved 3 changes. Set stabilization window seconds. 120 for scale-up to let pods warm up, change the scale-up policy from pods, 4 to %, 50 for proportional scaling, and set scale-down stabilization to 300 seconds. Also added a readiness probe with initial delay seconds, 30 so pods aren't counted in metrics until warm. The default scale-up stabilization window is 0 seconds, which means HPA reacts immediately to every metric change. This is the single most common cause of flapping. Always set it to at least 61-20 seconds in production. Without resource requests on your pods, HPA cannot calculate utilization percentages. It will report unknown and fail to scale. Always set CPU and memory requests on every container you intend to autoscale. If VPA is in auto mode and HPA is scaling on the same metric, e.g., CPU, they fight each other. HPA changes replica count, VPA changes pod size, causing oscillation. Use VPA in off mode for recommendations only. When using custom metrics, e.g., Prometheus Adapter, the HPA controller needs RBAC permissions to access the custom metrics K8SIO API. If you see unauthorized errors in HPA events, ensure the system, controller, horizontal pod autoscaler, cluster role includes the necessary rules, or create a custom cluster role binding. Use a load generator like Hey or kubectl run with a busybox container to generate CPU load and verify HPA scales up. This validates that the metrics pipeline and scaling policies work end-to-end. When HPA is configured with multiple metrics, e.g., CPU and memory, it calculates desired replicas for each metric independently and uses the maximum. This can cause overprovisioning if one metric is noisy or misconfigured. Always validate each metric source independently to avoid unexpected scaling. When debugging HPA, start with kubectl describe HPA to see conditions and events. Check if metric server is running with kubectl top pods. For custom metrics, verify the API service and adapter logs. Let's run through some common interview questions. How does HPA calculate desired replicas? Uses formula. Desired replicas equals ceil current replicas asterisk current metric / target metric. What causes HPA to show unknown metrics? Metrics server down, missing resource requests, or custom metrics adapter failure. Can HPA and VPA be used together? Yes, but not on the same metric. Use VPA in off mode for recommendations. And a few frequently asked questions. What is the HPA formula? Desired replicas equals seal current replicas asterisk, current metric value / target metric value. Why is HPA showing unknown for metrics? Metrics server not running, missing resource requests, or custom metrics adapter down. How to prevent HPA flapping? Set stabilization windows for both scale up and scale down, and use readiness probes with initial delay. To recap, HPA scales proportionally, not binary. Stabilization windows are essential to prevent flapping. Custom metrics make HPA application aware, but add dependencies. Never let HPA and VPA autoscale on the same metric. KEDA extends HPA for event-driven workloads. Always test your HPA configuration under load before going to production. Ready to go deeper? Up next, Kubernetes monitoring with Prometheus, then Kubernetes architecture explained, then Kubernetes network policies. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.